Okay, good afternoon, students. This is Mr. Gee with another YouTube video going over some of the ratio and proportion problems that we've been working on. I have one video that goes over the working together problem, and many of you are confusing the left to finish type of problem with working together. And I think the reason why is because the formulas look so very much alike. And maybe what a good thing to do would be a good thing to do is to go over the difference of these two formulas. This formula right here to the left is the one that we use for this type of problem, left to finish. The formula that we use for one where we're working together looks like this. Some differences to note is that on the difference between these two problems, if you look at the right hand sides, over here I have a 1, here I have a 1 over t. Well, the t for this problem is found right there. Do you see that? Now these R1s, here you can see I've got 3 terms here. Here I only have 2. This is for 2 people. This is also for 2 people. But what you've got to understand is that one of these people is going to be left behind to finish the job. Well, this is how much time. Right here will be how much time he takes to finish to do the job on his own. And another thing that's different right here is these H's. This H and this H represents how much time that Curly and Mo work together on their job. They both work on the same lawn for how many minutes? 10 minutes. Well, on this problem over here, this type of problem, they never leave. They stay together until the job is done. So how do I take that into account? Is by adding this third ratio. Okay. Whereas in the working together problem, these would stay as 1. On the left to finish problem, these will become the time. These H's turn into the amount of time that the two individuals worked together before one of them took off. So let's go ahead and finish this problem. I want to get rid of some of the stuff that I have here. Let me see if I can get rid of that. I want to get rid of that. Okay. Let's go ahead and continue here. Okay, so let's go ahead and read the problem. Mo can mow a large lawn in how many minutes? Well, Mo can do it in, it's not the right pen I want. Mo can do that lawn in 50 minutes. And since we're talking about Mo is the one that's going to stay behind, we'll find out here in a minute. So Mo can mow a large lawn in 50 minutes. Curly can mow the same type of lawn in how many minutes? Well, he can do it in 40 minutes. Okay, they both work on the lawn for 10 minutes, and then Curly leaves. So who's left behind? Mo. Well, we go back to Mo. How much time did Mo take until the lawn was completed? That's what RT is. So that has to do with Mo. This has to do with Mo. That has to do with Mo. And then the one last thing here, this has to do with how much time they spent together, how much time they spent together working before they left. So do you see the difference between these two problems and this one? You've got the H's, the T's in a different place. And now how long did Curly complete this stuff? Well, it takes him 40 minutes. So that right there has to be the 40 that we need. And then what does it equal? It equals one entire job. So hopefully you see the difference between these two formulas. And like I say, I've already got a problem posted for working together. So let's go ahead and let's fill in our numbers that we need. So H I know is going to be 10. So I've got 10 over 50 for Mo. Now, Mo is also the one that's going to be left behind, so the time left to finish belongs to him. So it's going to be done at his rate, which is T over 50. And then now we have Curly. He works a little bit faster. He can do the same type of lawn in 40 minutes. Remember, they spend 10 minutes together working, so that'll be 10 over 40. And that entire thing equals one job. Now, the mathematical principle that gets everything here working is the idea of a common denominator. And the common denominator that I need, I'm going to go over here and work, is I know that 50 times 40, if you take your calculator, we know that equals 2,000. So instead of having 50 here, I want 2,000 here. Well, I just can't multiply that bottom by 40 and get 2,000 on the bottom without doing the same thing to the top. So I make the denominator 40 times bigger, but I can't just leave the numerator 10. I've got to make that also 40 times bigger. So what we'll do, we'll go 40 times 10 to the top, 40 times 50 to the bottom, and we're going to do this all the way through. Well, we've got T. There's 50 on the bottom, so I need to multiply it by 40. So 40 times 50, 40 times T. So now I do this one over here. The 40 is missing the 50. 50 times 10, 50 times 40. And so if you notice right here, what's taking place is the fact that all these numbers right here, I'm just multiplying by 1. That's multiplication by 1. That's multiplication by 1. And that's multiplication by 1. So all these numbers like 10 over 50, I'm going to change that to 40 over 2,000. But it's just really the same number. It just looks different. It's the same value on the number line. Well, this has to equal, well, 1 over 1. I've got to have 2,000 on the bottom. So I'm going to multiply 2,000 to the bottom and 2,000 to the top. So you can see that 40 times 50 is 2,000, so I'm going to have 2,000 here, 2,000 here, 2,000 here, 2,000 here. And one thing that I've been trying to drill into you guys to make sure that you understand is that when all my denominators are the same, I can cancel them. So now the equation that I end up with, 40 times 10 is 400. Plus 40 times t is 40t, and 50 times 10 is 500, and then all that's going to be equal to 2,000. Okay, I'm going to collect my like terms. If you see, I've got two like terms. Those like terms are right here and here. Now, why are they like terms? Well, they're both numbers. This one has a t with it. So 400 plus 500, that is 900. So 900 plus 40t equals 2,000. Now I'm ready to solve. Got my equation simplified. Well, let's subtract 900 from each side. We know 900 minus 900 is 0. The 40t will just come forward. 2,000 minus 900 will give me 1,100. And now to finish this, all I have to do is divide by the 40. So I divide 40 to the left-hand side, then I also have to do it to the right. And if you take your calculator, you take 1100 divided by 40, you get 27.5. And what am I solving for? The amount of time it takes Mo to finish the job when he's left alone. So my unit is in minutes. Now, a good way to check your problem is to go back to your original ratio right here and put 27.5 in for t. Take 10 over 50 plus 27.5 over 50 plus 10 over 40, and what it better equal 1. And if it does equal 1, that means you've done the problem correctly. So this is a left to finish proportion problem. If you have any questions, you can come in and we can sit down after school and go over to some of this material. Remember that you have a quiz tomorrow, and this is our retake on this, and hope you do well. Thanks, and have a happy day. Bye-bye.